SLLA stands for, I'll let you find out, but I'll talk about a little bit background about SLLA, SLSA, so SLSA. Let's call it SLSA, it's easier, like the source SLSA. Now, SLSA is an open source framework, and it was released by Google at some point last year. And prior to that release, SLSA was called a BCRD, Binary Configuration for our internal artifacts. And that was a framework Google used internally to build our software. And we look at it, we'll kind of go, look, let's package this one given to the community as open source thing. So once the SLSA framework was released, I was looking at it, I thought it was really good. And what I did also is picked up some of the very common open source tools, such as SonarQube. And one of the probably good, like I'm not advertising for any vendor products, I'm just trying to, coming from a security professional perspective, a software supply chain or composition scanning tool called a Sneak. And I kind of go, look, why don't I bring them together? And based on this SLSA framework, to build a CI/CD pipeline, okay? Hence this presentation over here. So what I'm going to do today is to take you through a little bit around the background of SLSA and how you can help. And I'm going to show you a reference architecture. This reference architecture is based on Google products, but no worries. If you're using other clouds or if you're using on-prem, you can use the same reference architecture as well. You just need to swap out different components. For example, if you're using Jenkins, using GitLab, fine, will also work. Questions, put in the chat, or if you really like to, you can just interrupt me anytime. We have a smaller group, so let's keep it interactive. Righty. So let's probably talk about software supply chain security.
Hey, Ken, you are mute.
Yeah, Ken, your mic is mute.
Ooh. Have I been on mute all the time, or just now?
No, just at the time. Yeah, at the time when you show this page.
Okay, no worries. Okay. So talking about the software, how it's being built today, it's like a Lego. People don't really write, all the modules from scratch for very good reasons. Okay, so this is a example of the software. Let's say e-commerce website. You have on the landing page, on the login page, you have the login modules, you have the chat bot, you have the shopping cart, you have something like gift ideas or building kind of videos, etc., etc. And there's many things running in the background as well, just to capture a telemetry of this application. And all of those are modules, and people don't write these modules from the scratch. There are many modules on the market, open source or commercial ones you can use. They can really help people to boost the productivity and time to market. Okay, but they also creates a problem. One of the recent things like Log4j and a SolarWinds kind of attack, really happening from the supply chain. And sometimes the modules or libraries that you're using closest to your software building, for example, you kind of go, I want to use this particular chatbot module, but that particular chatbot module is built upon other modules. And it's like the Russian DAO kind of different tiers. And then once you trying to build that software, and sometimes when you're trying to plug the software binary to your static code analysis tooling, you cannot find it because static code analysis sometimes stays at the code level, what the code you've written level. It's not going to dive deep into the composition and tiers of packages to let you know if you are happening using some of the vulnerable packages like Log4j. So I don't need to talk about more about all the attacks. You guys know more if you type in software supply chain attack. Many of them will pop up. And there is a Google cybersecurity action team report, which I can share the link a little bit later on. We found there's 15 something times of increased supply chain attack since last year. So there's quite a lot of quite commonplace because web defense is becoming very, very common. Almost everybody is having, the WAF, having fairly adequate application security practice So it's probably difficult coming from the front, from the head-on. So the attackers will think about how do I infiltrate your supply chain. Now, how does SLSA help? So SLSA, you can think SLSA is a checklist. It's also a standard. It can work as a standard. It's looking at this very simple diagram of overly simplified software like development lifecycle and looking at different places where are the threats that could occur at each stage, and how do we then provide controls to mitigate each of the threat at each of the stages. And also for each controls, we can also look at work where we can go wrong. I'll probably leave this one for you to watch later on. So it can be coming from a vulnerable package from your software code, okay? And it can also coming from your malicious, it can be a vulnerable package as part of your update. You want to push out to existing software, which is what happened to the SolarWinds, right? It can also be the vulnerable source code itself. It can also be combinations of a pipeline being compromised. There's many things that can go wrong. So with the SLSA, it gives you the framework, a checklist. Go to each of the checklist. It gives you a recommendation. What does it look like? And how good it is. It also gives you different levels from level 1, 2, 3, and 4. So obviously, level 1 is the basic level. Level 4 is most advanced level. For each of the controls, it gives you the table. So from the source, build, provenance, and a common security practice. And it gives you, hey, what does level 4 mean? What do you need to do to achieve level 4? By the way, this is a framework. It is not a certification. So I don't think there is a, from the Google perspective, this is open source. We don't have a certification program per se to say, hey, look, let me assess your pipeline to give you, sales certification. That's not in place right now, but feel free to take this framework and customize it. I think some of the enterprise customers, you could take this framework and build your own. And you can also use this framework to control, or not to dictate, rather to guide your internal software build, how the pipeline should look like. Now, you can find the SLSA framework on slsa.dev, slsa.dev. So it's got all the information in there talking about, hey, this framework and explanation of each of the levels, what you need to do, okay? Now, what I did was I've taken this framework and I built a reference architecture on a GCP. Again, like I said, it's on GCP, but we will very soon find out it can also be built on any cloud, on-prem as well. So if we look at the high-level architecture of these, this reference architecture, it's really based on the same framework I've been using over and over again. It's a directive controls, preventative controls, and corresponding detective controls and responsive controls. So it's like closed loop. Directive controls essentially is, hey, you should do this. It's your guidance. So over here, I've taken SLSA, obviously, is a standard, right, as my directive control source. And I'm using the source, this SLSA framework as guidance to build my preventative controls and the rest of it. Now, this is a high level, probably abstract level kind of architecture. If you want to swap this view with particular products, this is what it looks like. It's kind of busy, but don't worry, because I'm going to chop it up and then take you through each of the steps bit by bit. So from probably 30,000 feet kind of view, my opinion of seeing this end-to-end flow has 3 parts: the build part, the deployment part, and the runtime part as well. So I've taken this reference architecture based on a Kubernetes based container workflow. So essentially taking your source code all the way from developers' workstations, going through the pipeline, deploying on the Kubernetes clusters, and promoting from probably non-production clusters to production cluster, and expose it out. Okay, and the demo today will be focused on the first 2 parts, build and deploy. Okay, and one thing I want to also introduce in here is called binary authorization, which we're going to have a look a little bit later on how it works and how it works in action. It's really about signing your containers, making sure the containers you are running on your Kubernetes cluster is going through all the checks and balances you have built as part of your CI/CD pipeline. So we can starting with the first part of the journey, the build journey. So I've given each of the flow a numbered dots. So 1, 2, 3, 4, 5, 6. These are representing the flows, essentially how the workflow flows. And you can see some the letters as well. The letters are indicating the integrations, which I'll talk about after the flows. So you can take this one to swap it out to other products. Feel free, and that can become your own. Okay. So let's starting from step number 1. Step number 1 essentially is me being a developer. I'm working off my local IDE or even cloud IDE, any IDE, and I'm trying to push my code to the source repository. Once I push my code to the source repository, particular branch, which you can configure, let's assume simplest way, like a demo way, into the master or main branch. And that particular pushing event will then trigger my CI. Over here in Google Cloud, we use Cloud Build, which is fully managed CI. It can be your Jenkins, it can be your GitLab, okay? Or any other CI tool. So it will then trigger the CI. So CI will do something, first thing CI will do is trying to build the software binary. So it's going to, in the ideal world, you wanted to go to an artifact repository where all the packages are downloaded by you and also scanned by you. You know what, they are good, they're known good packages. So I've seen some of the banks they've done this. They run something like a JFrog artifactory. So they pre-download lots of packages with the certain versions. They keep the registry and then continuously scan the private registry of all the software dependencies. And then they only allow the software building process to retrieve packages from the known good private artifact repository. This is like extreme level. It's really, really good level as well. I think most of the companies probably are still using the public ones, which is fine as well, because we still have some mitigation controls. Now, once the software is being built with all the dependencies, etc., all the libraries, etc., this is when the Snyk essentially is a software composition security scanning tool. There are other ones like Black Dark or other vendor products you can use. So what Snyk essentially does is to go into your tangled, tiered dependencies and libraries to look for if you happen to be using some of the vulnerable packages. So it can be, you might be using chatbot, and chatbot's having maybe the chatbot is written in Java and it has a logging feature. You know what I'm going into, right? You might be using log4j vulnerable version, but you're actually using chatbot. It didn't realize. You probably underneath the chatbot kind of package, you are using a vulnerable log4j library as well. So Snyk will help you to map out. It will go really deep and find out if you have anything. Now, the next step is your static code analysis. Over here, I've chosen a open source one, very common one, SonarQube. So over here, it doesn't have to be this way, but I've built this reference architecture this way, okay? So I wanted to leverage the SonarQube automatic, the quality gate to automatically fail my build or pass my build. So in the quality gate, I'll show you later on in the portal, you can configure a percentage of security findings or any other parameters. There's a few parameters where you can configure. So you can set a level, a threshold. Any code scan that's producing results over the threshold, you will then fail, or under the threshold will pass, something like that. So we want to, over here, want to leverage the SonarQube. And once you go through all of them, step number 6 is really about building a container and assigning a container using binary authorization. So binary authorization is something on GCP, it's managed service, but if you want the open source ones, it is there as well. It's called a Kritis, C-R-I-T-I-S, Kritis, yes, Kritis. It's an open source software you can use. It works the same way as well. Now, over here, essentially what you're doing is, look, my container at step 6, it's been built, okay? It has gone to the sneak scan. It has gone to the SonarQube scan, okay? So I know two things I know. First is the code quality, code security from static code analysis perspective is good. Second thing I know is it gone to the composition scan. Now over here, you can even go one step further. You kind of go, look, if sneak result returning high level, like high severity or critical severity findings, you can fail it. Okay, over here in my demo, I didn't do that. Okay, but you can definitely build that logic into the CI. Now, once you sign the container, you will be then pushed to the container registry. Again, in Google, we have automatic vulnerability scanning the container registry, containers that have been pushed to the registry. I'm pretty sure other clouds, they do the same thing as well. If you run your own container registry, like the Artifactory from JFrog, they have a similar feature as well. Now, by now, we've taken the code all the way to the containers. The next step is when we're trying to deploy the containers to Kubernetes clusters, right? So we use another thing in Google called Cloud Deploy. Essentially, it's a CD tooling. Again, you can use your own. You can use your Jenkins to trigger the sort of like kube controller kind of stuff. We're using other frameworks like Scaffold, custom, that kind of things for you to deploy containers into different Kubernetes clusters. That's fine. It's all up to you. But over here, I'll be using the Cloud Deploy managed CD. Now, over here, Cloud Deploy will help me to kick off GKE releases. So in my example, I've used 2 clusters, one representing a dev or non-prod cluster, and it will then deploy to that cluster first. And I've set a manual step for me to promote, if everything's okay, promote my non-prod, the container to the production Kubernetes cluster, okay? Now, 11, 12, and 13 is really about using the Google's web app and API solution to expose the container to the internet. So do things like the load balancers, WAF, that kind of stuff. I'm pretty sure other clouds have the same thing as well, and they can also build the same stack on-prem or anywhere else. Now, for the integration, now we're talking about numbered English characters, A, B, C, D, E, F, G, right? This is talking about integrations. We just went through the flows, how end-to-end, how do you take code, the container, from container to Kubernetes cluster, and how do you then expose the containers that are running on the Kubernetes cluster securely using load balancer and WAF, okay? Now we're talking about how this integration works for this reference architecture. So in this reference architecture, step number 1, or A, let's call it A. It's not compulsory, by the way. So because I'm using Sneak as the center of my software composition scan, so I wanted to have Sneak to hook up into all the multiple places to understand my software supply chain security at all time. So there's 2 places I've taken the Sneak into. The first place is the private artifact repository. Okay, we talked about before. In the ideal world, you want to pre-download those dependencies into a private registry that you own, and once you've done that, you want to scan all those packages for vulnerabilities. Okay, that's the integration A. The second thing, what Sneak also does is to hook up to your IDE. So in my example, I'm using VS Code. Okay, there is a plugin on my VS Code from Sneak, and as I'm building the software on my local IDE, you will actually tell me if I'm actually using vulnerable packages on the VS Code. Okay, before I build the containers, before I do the rest of it. As a developer, I will have very early feedback. Very, like I would like to say, shift left. Yeah, it's really shifting very left. Even before I build a container, I already know I might be using something bad. Okay, that's the integration B. Now, integration C is to have the Sneak to conduct the same scan against your container registry. It can be the Google one or AWS one, any Azure on-prem, or even just a object storage. Scan that. Now, step D is having the binary authorization. because binary authorization is really about signing certain artifacts, signing the binaries. So when we talk about signing, we'll have to use the key pairs, right? The public key and the private key. And where's the best place to secure the key pairs? KMS, the key management systems. Every cloud provider has that. So it's highly recommended. Over here in Google, we use our own KMS. If you run your own open source binary authorization using Kritis, I also recommend you to use the key management system to store the key pairs, okay, for the signing. Now, moving on to the second part of journey of integration. So binary authorization over here in Google Cloud is integrated with GKE, the Google Kubernetes engine. So it's automatically integrated. So it's a few settings. You can ensure only binary authorization authorized containers can be deployed onto your GKE. So you cannot simply deploy any container image from, let's say, Docker Hub or anywhere else. You have that choice. Okay, I'll show you the binary authorization in a demo in a bit. Now, FGN, HIJKLs all around Google Cloud, but I'll talk through what I do. So I'll talk through what I do, and then you can think about if you're running different cloud, how you will then swap these, or how you can replace these functionalities with something you have. Now, Security Command Center over here, again, in Google Cloud, it integrates with the GKE cluster automatically. You don't have to deploy any agents. So it's one click, it understands it. So what thing here does is the Security Command Center looks at the container at the runtime, okay? So in the ideal world, or in the best way, the best practice, when you run a container, the container should do its job. So if you let's say you run a container, it's running right now, the container shouldn't be doing anything apart from serving its own purpose. For example, if the container is an API, you should just be taking the API calls and returning the results, okay? Container at the runtime should not executing any command. You also shouldn't be downloading something else and trying to install something on the fly, okay? And that's a very great indicator of compromise. So if your container is a compromise, think about it, the kill chain. If I were able to compromise one of the containers, the first thing I would do is to drop some binaries and to create a backdoor or trying to move laterally to other containers, etc. And those are the changes will be detected by Security Command Center, and any other vendor tools will help you detect as well. Basically, the deltas or abnormal activities of your containers at the runtime. Now, you should also use WAF, and you should have the WAF findings in the ideal world to be integrated in one place. Okay. In Google Cloud, we have Security Command Center, which I talked about just now. It detects the container threat at runtime, so you can see all the findings. And it also brings in the WAF logs into the same place as well. So I think other clouds have similar products to do the same thing. And also, another thing you also want to do is conduct continuous web app scan. It's almost like a mini penetration test from the outside, okay? So everything you do so far is really talking about from the inside. But you still want to understand, if you are an attacker or if you're a user, you're coming out from the outside, let's say kensappdoor.com, what does it look like? What sort of vulnerabilities you are exposing from the outside perspective? So you want to do some automated, lightweight web app scan. So again, over here, Google Cloud will have Cloud Security Scanner. It's managed service and also scans the code, scans your app, and it brings the findings back to your Security Command Center. Okay. Now, Conical is a SIEM. So if running any SIEM, it's also recommended for you to export all the findings into the SIEM, where you can bring the workflow to your Security Operations Center. And also you can create some like SRE kind of, or DevOps kind of logging natively in the platform we are running, okay? Now, quite a bit of information, don't worry, we'll have recording, and I'm happy to share the slides with everyone here today as well. There's nothing secret about it. Another thing we want to move on to is the extending the reference architecture we just talked about, okay? Now, the reference architecture I've built just now is roughly based on CSA level 3. It's not level 4 yet, because as you know, not everything in a framework or any standard can be realized fully just by technical stuff. There are processes in place, there are how you use things in place as well. So over here, I'm talking about different things in swap out. For example, cloud build, you can use Jenkins, GitLab, Zool, Circle CI, etc. But also, over mapping here, I've left some words in red. So if you're really thinking about achieving CSA level 4 as per definition, what you can also do is, for example, one of the requirements for CSA level 4 around the source control is to have 2-person review all your code, and automatically we think about the pull request review kind of process, which lots of companies are doing this. I just haven't built that as part of my demo, so I'm calling it out. You can use the pull request kind of workflow. So in addition to all the scans, you're building your CI at point of merging, or even before that, you can think about having a peer engineer, or even having a security team or application security team to review the code, humanize, before you merging into the main branch, okay? That's how you can do over here to bring that to level 4. Another place you can do is to leverage the at the build stage, you want to run totally parameterless kind of build. So the rationale here is, so the code scan in my demo is inline kind of command. It basically is instructions in almost like a shell script kind of the format to say, hey, scan this, scan that. If it fails, and do this and that. Okay, that's still vulnerable. Why? Because people who have access to manipulate or write the flow I just talked about also have access to remove them, to bypass them, right? So in the ideal world, you probably want your pipeline to be calling an external service, and these external services will conduct those scans. And how the scans performance and what's the quality gauge and that kind of stuff will be controlled by external. So I think in an ideal world, you will have SRE or DevOps team to be calling a centralized security services, and those services will be exposed as APIs, which the pipeline can call. And every time if you call, it scans, is good, and then there'll be events feeding back to both the application team and the security team. If it fails, there will also be an event which both teams will know. Okay, in the ideal world, you want to do that. You want to separate these two things, not bundle them together. That's level 4 requirements. Now, none of the things around level 4 is, I will talk about in my demo, which I didn't do, is the private registry of your dependencies and packages. It's highly recommended. It's a bit hard to do, I understand. You can also, I think you can take an iterative kind of approach. You build a private registry to start and start bringing packages as required into the private registry as you build out your enterprise or company-wide kind of private registry and maintain it. Now, another thing is reproducibility. So another thing you want to do is for each build going to your CI, you want to have a hash value of that build. So hash is unique, right? Anything changes and the hash will be different. So every build should be recorded. So if the build is successful, it's good, it's all green, that should be a hash value to be kept at a key value store. You know, it can be heavy as MongoDB or Bigtable or something else, DocumentDB, whatever it is, DynamoDB in AWS, or something else you build, key value store of the build and also the hash value of that particular build. That way you will have the entire chain of trust, understanding, hey, how many builds are there and which builds good, which builds are bad. And you have the not only the ability to trace them, but also you have the ability to trying to reproduce some of the if in a forensic kind of situation. That's more. We only look at the red ones, okay? Now, also over here, we're talking about attestation. Attestation really is about, hey, look, when we're scanning to your CI process. If it's good, how do you ensure it's good? You can use digital signature, right? Over there, we talk about it. In my demo, I'm using the SonarQube, its own quality gate, but I didn't sign that particular result, the step. One thing you can do in addition is, for example, if a quality gate from SonarQube give you a thumb up, next step in your CI, what you can do is to leverage binary authorization or any other tool to query SonarQube to just basically as assurance to check to say, hey, SonarQube, was the scan just now good? Was it secure or was it green? You use API to find out that. If SonarQube returns, yes, it was good, and then you go, fine, let me sign this particular step that you've just conducted. So basically, it's rubber stamping the action of the SonarQube scan. Same applies to your Sneak, the software composition scan as well. Same thing. You can choose to query the tooling itself, getting a result, and based on the result, and assigning the particular build step as well. Now, next one is about it's similar to separating the build and configuration of the scans, etc. Over here, in my demo, everything's in a cloud build, so it's almost like my dev team and security team on one team, but in reality, lots of big companies, there are different teams, etc., and you're trying to mitigate, rogue and insiders, that kind of threats. So over here, you want to lock down those scanning tools or almost like security plugin permissions. You don't want everyone to have access to them, especially not giving the people who run in the pipeline steps to be able to change them. Okay. Now dependencies. Let's look at this one. What did I put in there? Yeah. So for the you can in the provenance last part, which is of the build containers you want to deploy to Kubernetes cluster, you really want to have a separate signing process. You can use something like open source like GraphES to implement some, additional controls. So in Kubernetes, a little bit probably tangent into Kubernetes. Kubernetes have something called admission control, which becoming very, very popular. You can write open policy agent Rego kind of languages to interact with the admission control. You can think admission control is the gate in front of your Kubernetes API. So only things that pass through the admission control can interact with your Kubernetes API, okay? So what you can do is consider bringing different policies at the admission control layer and bake that policies as part of your signing process, your binary authorization process, okay? So that's essentially, I know it's quite a lot of information to digest, but the gist is, first of all, this diagram over here, this architecture over here, take it and use it, swap them out. Most important thing is think about it, my train of thought, my opinion of why I'm doing something, why did I design different steps, and why did I need both static code analysis and security supply chain composition kind of a scanning, and why did I design each sort of integrations, and also if you wanted to be SLSA level 4, what you need to do more based on existing reference architecture. Again, the source of truth is at a SLSA website, slsa.dev, slsa.dev. Now, that's all you've done, bringing all the code to running, to serving your customers. One part I also want to mention is around the observability and the workflow. So it's really concerning the IT operations team, your SOC, et cetera, et cetera. So I've taken a view of, if I'm security ops, SecOps people, I often, when I go to work, I'll look at different dashboards, right? That's what I look at if I'm a SOC kind of analyst. So there's probably a few dashboards. The first dashboard I'm looking at is the tooling native dashboard from SonarQube, from Sneak. Okay, that's probably places I want to go to. The other dashboard, if I'm running a cloud workload, is the cloud kind of built-in dashboard. For example, like in GCP, we have cloud monitoring dashboard. and Azure have your own AWS, so does it. And the third dashboard I might be looking at is my SIEM dashboard. Over here, I've used Chronicle, which is our own SIEM, Google SIEM, but it can be your own, it can be IBM Curator or anything else. And the fourth place is the centralized security tooling natively in your cloud. For Google Cloud, it's Security Command Center, and for AWS Security Hub, etc. And Azure will be Security Center. So these are the few dashboards. Unfortunately, we'll have to look at. There's a way you can bring them all together into the SIEM, perfect. But I'm just talking about even before integration, what sort of intelligence you'll be looking at for each of the dashboard, each of the source of information. So for example, over here, we're looking at is the source code secure, if the all the software building blocks, libraries, etc. are secure. And then we're looking at if from the cloud monitoring perspective, we're looking at my entire pipeline, how many deployments or builds are violating the controls I'm building in. So it can be a good indicator, because if there are so many failed or violations, it can be one of two things. I think one is a misconfiguration. It can be an error in your code, or error mismatch of your code and the scanning, etc. That's an indicator for you to look at it. The second thing can be someone's trying to do dodgy things, right? Continuously bypassing your controls but couldn't do it. So either way is a good indicator for you to check it out. Now, for the SIEM, again, it's for detection rules, and usually SIEM has more intelligence, not just the logs it's ingesting into. It's also, most of the SIEMs will be infused with threat intelligence, which you purchase or it comes with the SIEM, etc. So that infusion can give you a different layer of indicator of compromises. Now, going back to the cloud native, the things like Security Command Center. So you can look at the shortest amount of time, look at the runtime application of your containers. And also often this kind of tooling has something called cloud security posture management, which is essentially looking at the configuration of your cloud assets. For example, is your Kubernetes cluster configured correctly? Is your cloud bucket is configured correctly? That kind of stuff. That's where you can look at it. Now, if we turn that same way into a recommended workflow, okay. So I wouldn't spend more time. I should talk about quite a bit over here. I want to spend some time on the demo with you. So essentially, you want to bring it all together and to bring a closed loop again. So you want to observe what happens and look at failed events or abnormal events, and going back to your workflow to improve it, or use that particular indicator to conduct your investigation. Cool. So exciting parts. We're gonna look at the demos. Before that, do you guys have any questions? I can't see the Microsoft Meet.
Currently, there's no questions that posted in the chat yet. I think we are trying to digest and understand from your presentation first.
Sure.
But it needs some time. Yeah.
So no worries. I understand that. I will use the demo to talk through what I just said.
Yep.
But in a demo way. Okay. Cool. So can everyone see my screen? I'm sharing my whole screen now. I have the GCP console. I have the VS Code.
Yes. Yep. Can see.
Okay. Fantastic. Okay. So in this demo, what I did was I've chosen a very simple. I just basically went to GitHub. I searched node example. Okay. I've chosen one of the smallest project because I don't want to spend too much time building a project, and because you guys would be waiting looking at the thing spinning. So it's a smaller project, a very simple project. Over here, a few files we need to look at. The first one is my pipeline design. Okay, this is essentially the cloud build GCP pipeline, what it looks like, and very easy. Zoom in a bit, maybe. Very easy to understand. My first step, like we talked about before, I want to do a sneak scan, software composition scan. Once I've done that, I want to do a SonarQube scan, which is the the static code analysis scan. Okay, over here, I talked about I want to use the SonarQube, its own quality gate to approve or fail the build. So I kind of go wait for the quality gate. And all the secrets I've used secrets manager in GCP, so I don't just put the token directly into the build. It's good practice as well, by the way. It's in reference architecture. And once I've gone through these two, what I want to do is to build a container. So in building a container, every build will produce two things, very, very important. First one is the short shard. The short shard essentially is the build. Every build will produce a shard. Okay, the shard input of the shard is like time, that kind of stuff. Anyways, every build you have unique shard. And the second thing important over here is your image digest. Okay, every container image you build will have its own digest, shard value, shard digest as well. These two are unique. So these are identifiers to identify each unique, even each container versions you've built, okay? So it's over here. Now, once I've produced the container, what I want to do is to assign those containers using binary authorization. So over here, I used the binary auth in GCP to assign my container. As you can tell, when I'm assigning a container, I'm really assigning the actual digest of that container. So I'm not assigning the container, for example, Nginx. I'm assigning Nginx build like a whole string of the digest, that particular one. Okay, only that version I'm assigning. Now, once I've done the build and assigning, I'm going to just to push my workflow to the next step into my cloud deploy, which is helping me to deploy my container to the Kubernetes cluster. These are the substitutions. As you can tell, I use the secrets manager to replace the tokens. I didn't put the tokens in plain text over here. Good practice. Now, this is the build part. We'll look at release part. So in the release part, essentially is triggering my CD, okay, continuous deployment. Now over here, I need to, on the fly, produce a Kubernetes manifest, basically saying, hey, look which container it is. So over here, I replaced, over here, this is the template Kubernetes manifest of deploying a pod, okay? So over the image over here, I've used the short shard and replaced as the, let's call it indicator. And at the deployment stage, because I already have the image digest from CI, what I can do is to dynamically change that particular file to have my short shard and image digest. So in the deployment phase, I'm only deploying the image that's been signed, okay? And you will have that file. Now, going back to GCP console, I'm going to zoom in a bit as well. Each build takes about 5 minutes or so. So I ran the build around just before lunchtime. So I don't need to run it right now, but I'll run another one. So this particular build was successful. Let's look at why it was successful, okay? So different steps showing over here. Sneak scan, so on a kube scan, building the containers, signing the containers, and pushing to deployment. So all the things are perfect over here, so it's fine. Let's look at my SonarQube configuration. This is my SonarQube portal, okay? So this is the scan I did. It has timestamp 2 hours ago. It's a simple, very overly simplified node project, so it's pretty clean from a static code perspective, okay? So one thing I want to do is to show you the quality gate, maybe. So the default one, the SonarQube default one, it has like 80%, etc., etc., etc. So obviously my code was pretty clean. It will pass the quality gate. So in order to demonstrate how you use a quality gate, let's go back here. The only thing we can play around with is essentially the code smells, right? So one thing we can do is to set the quality gate to say, look, if something less than this, I failed it. So which I did. I created a custom version of quality gate. So I kind of go, if code smell is greater than 5, then failed it. So all I do is go back to this project, and I will then assign that particular one to my project. And if I go back to my IDE, I can then push it, the change. It will then trigger the build again. It's going to run for 5 minutes or so. Let's have a look. It should have kicked off. Fantastic. As it's running, I'm going to show you different things. Okay. So if you remember, I talked about I used to sneak the plugin with my VS Code. So on the sneak, these are the projects I've just conducted. As you can tell, it's pretty bad actually in terms of what the results. If you remember from the Sonar Cube static code analysis, they were pretty clean. But if you're really looking at the examples over here, the sneak actually goes into the vulnerable packages. It found out other things that your normal static code analysis wouldn't be able to find. It actually found the high findings around using some my sample project actually using some vulnerable packages. Again, it's different view over here. It has 8 high findings. Well, if we're going back to static code analysis, everything's rosy, right? There's a difference. Now, this particular view here is from Sneak, and on the same view, if I'm a developer, if I'm going back to my IDE, with integration of Sneak, I can actually find out the same information over here as well. As I'm coding, in a node, I have a package JSON, essentially talking about what packages am I going to use. And Sneak go, okay, I got it. Let me do some scan to let you know if the packages you're using, it has known vulnerabilities. It will tell me here directly. Now, as it's running, I'm going to show you the binary authorization configuration as well. So binary authorization, simplest form, is basically doing a digital signature. Full stop. It's taken any input. It can be input of your container. It can be input of your something like build or whatever. Sign it and produce the digest, and use the same tooling, binary authorization, to hook up with the Kubernetes cluster. So Kubernetes cluster will only allow deployment unless it's been approved or whitelisted or attested by binary authorization. So over here, I've used different ways to use binary authorization. I used a tester kind of mode. A tester essentially is someone who can attest something is good. Okay, so I've created a few testers over here, and the one I'm using today is called a SLSA attester. Essentially, in the SLSA attester, you can configure what are the keys you're using. As you can tell, I'm using my KMS to manage my keys, so I don't have to produce them. KMS manages for me. Now, back to my policies. This is a little bit words over here, a bit wordy. So I kind of go, look, I only allow images that have been approved by this particular tester to be deployed on this particular cluster. So in my demo, I have 2 clusters. I've set the same policy for both clusters. Okay. So if we go to the cluster, the reconnect, just time that. Well, what I'm going to demonstrate is, if you remember over here, I set the policies only SLSA attested images can be deployed. We can do it. We can do an example to look at. Let's say what a pod I have. I can try to deploy a Nginx image from Docker Hub. So I can just go Nginx image Nginx. It's failed. Okay, it's quite a lot of words over here, but we can read it together. So essentially saying it's denied. Denied by binary authorization cluster admission rule. Okay, so basically saying, look, this particular image you're trying to deploy is not attested by SLSA attester. Okay, so I'm not going to deploy at all. It's not going to run. So how do I get an image that can run this particular cluster? Let's go back here. Oh, as you can tell, it failed. Okay, let's look at why it failed. Do you remember what we did? Okay, a bit of a recap of why it failed. One thing we did was we went back to the quality gate. We changed to custom quality gate, right? I'm gonna go if the code smell is greater than 5 and failed it. And over here we have 13, which is greater than 5. And obviously my cloud build will fail it, okay? Let's have a look. Yes, at the bottom, quality gate status failed, okay? That's how you then leverage the SonarQube is building quality gate to conduct it. So I'm not going to run again, I'm going to use the previous one. So over here, this is the successful build, as you can tell from before. It took 5 minutes, and then deployment took 30 seconds. Let's look at the deployment. Recap, what did we do in the deployment stage? We're trying to ingest the short SHA and image digest into the manifest so I can deploy it, right? So if we look at the results from here, this is the image, essentially. That's my registry, my container name, and that's the short SHA, and this is the image digest, okay? So what I'm going to do now is I'm going to copy all of this. So I can use touchpad better. Okay, let's go back to Kubernetes cluster. We're going to do the same thing. We're going to run a test, but this time instead of any random container, I'm going to use that particular one. It's created, no more error. Why? Because at my previous build, I've already signed these particular versions of a container, so you could run on my Kubernetes cluster. Now, I want to quickly show you the cloud deploy as well. So previously, this is from 16 minutes ago. So I pushed something and to my dev cluster, and by a single click, I can promote that to the production cluster as well. So we'll populate the rollout name. You can have your custom one as well. So you redeploy, you would redeploy the container into my production cluster. So I think we've got 5 minutes left. So I want to stop over here. Do you guys have any questions, or do you want me to unpack a little bit further for any of the sections?
I saw one question from Joseph in the chat. His question is, I think it's a bit short here, but I think what he mentioned is any subject on Jenkins X. And another, I'm not understanding whether that's another part of the question is fully connected with your subject. So I guess maybe his question is about whether this demo or this SLSA solution can work with Jenkins X or Jenkins.
It can. So if I may go back to the reference architecture, just use this one, it might be easier. So over the reference architecture, my core CI/CD is cloud build, and you can swap it out. You can swap cloud build with Jenkins, like these steps. It can be replaced with Jenkins. It works exactly the same way. Any CI will work. And in the table over here, it's also talked about, cloud build essentially is a CI tool. You can use Jenkins, GitLab, or Circle CI, or any CI tool will do.
Good. So firstly, I just want to check with Ken here. If we interrupt here, or if we continue to ask some questions, will interrupt some of the parts that you still want to show, or do you want or the demo and things is already completed here?
So I've done all my demo and presentation. Yeah.
Okay. I think Joseph has a follow-up part. If you can see the meeting chat.
Jenkins X. I'm not quite familiar. Joseph, do you want to unmute and let us know? Maybe other participants on the call will be more familiar with Jenkins X.
I'm Joseph. Can you hear me?
Yes.
Okay. Jenkins X actually is fully designed the CD on Kubernetes. So basically, it comes with the difference of the components regarding on the registry, the pipeline, and so on. So I'm thinking about how it means your solution in where can plug in Jenkins in which component in certain extent, because in Jenkins X this project is designed to complement the run on the Kubernetes for cloud native applications, and also around the Git, the source for versioning.
Yeah, is Jenkins X different to Jenkins?
Yes, exactly. It's not the upgrade version. It's a totally rewrite version.
Okay.
That come with the integrate with the Kubernetes, the ham check, okay, to pull down the image.
Yeah.
They also have the Git var, actually to store the security, the secret key.
Yeah.
And also they will activate the very popular, it means Kubernetes, the pipeline. That is the use it for cloud native, because the cloud native is different from VMs. Okay, the behavior. Jenkins is the serve for VM. So, but the Jenkins is a totally to serve for the cloud native dynamic environment, and also link with the GitOps as well. So I'm trying to understand your solution, the tools you mentioned that I know this. It means this finding, and then how can it means on GCP, the platform to link to Jenkins S to automate the whole process from end to end.
Sure, I understand the question. So Jenkins X is, like, first of all, Jenkins can work with Kubernetes as well. Lots of my customers using Jenkins to run, you call it cloud native Kubernetes, it works totally fine, okay? Now, Jenkins X, I did a quick look up, it's a continuous delivery tool, okay? So in the solution, if you wanted to use Jenkins X to replace, to swap it out, it's over here. I'm going to share the screen. So over here, in my example, I used the cloud deploy, which is native to GCP. Over here, I think previously people use Spinnaker, GitLab, that kind of stuff to do continuous deployment. You can swap it out. Here can be your Jenkins X. It's part of deployment, and the Kubernetes cluster, if you're using GKE, perfect. You can use binary authorization, just like how I used it. If you're using a Kubernetes cluster like you built on your own, you can use the greatest, like I talked about, and the GraphAS. So essentially, Jenkins X is continuous deploy CD, which will be this part.
Okay, so that means I can plug in the Jenkins X to for the CD that's part of component on your solution.
Correct.
Am I right?
So, yeah, it will be like deploy part. So instead of using cloud deploy, you can swap with Jenkins X. I'm pretty sure it does CI as well. So you probably can just run the entire thing, replacing both cloud build and cloud deploy using your Jenkins X.
Okay, I have a last question. I saw your image a demo regarding the YAML, the kind that you are using the POP. Can I put the kind leveraging using the deployment for just the provision container, everything?
You mean the deploy, like what I'm showing now? You're referring to this part, right?
The kind, because I see your kind is the pod. I'm asking if I can replace by deployment YAML template, so as the better to managing the overall the life cycle of the container.
Yeah, you can. So the same thing in a deployment, you still have to define a container, right? I mean image. So same thing. You can use the same. You can just use my code actually, just to replace it. I have this is again, it's overly simplified demo, just for demonstration purposes, but some code you can reuse. I have it on the GitHub as well. I'll share with everyone who participated late after this session.
Thank you.
Cool, no worries.
So maybe let me ask some preliminary questions. I think it's or elementary questions, because I think the previous discussion is really great and really understand something here. But back to the very basic things before some other participants can want to ask questions. Is the SLSA the one the SLSA, is it more for the CI/CD cycle, or is it as if we have some of the cloud environment, can we still use this scheme to perform some tests if we are not focusing on development part?
Yeah, so SLSA, it's about software supply chain security or provenance or integrity. It's a framework. It's a standard. You can talk about standard as well. So this is a website, but by the way, SLSA.dev. It has all the levels, like definition of levels. It also has detailed explanation of each of the levels. What does it mean? And some of limitations you may run across. And if you go a bit further, it can tell you each level of requirements over here as well. So for example, this is the table which I screen capped. We take that for example. So over here, what does build as a code mean? So if you have realized that, which level are you at? So if you want to have level 3 and 4, you've got to have this. If you haven't got build as a code, you are still at level 1 and 2. So essentially, it's like checklist for people to go through it. Again, does level 4 mean you're the perfect? It can be. It means you're better than level 3, better than you are yesterday, right? But it gives you the ability to grow with the framework.
So that means this framework is which includes the maturity assessment, some kind of maturity assessment functionality as well. And if the environment that we try to build is more as something as similar to infrastructure kind of setup, then not much development work plays in. Would it be wasting this framework?
No, you can't. So same thing. I can give you one example. When you're developing cloud infrastructure or even on-prem, you may be using infrastructure as a code, right? Terraform, that's called Terraform. You can also run Terraform unit tests. So in my previous talk, I talked about check marks, kicks. So essentially, this is a infrastructure as code scanning tool, similar to SonarQube. The same work. You plug in instead of Node.js, you put in Terraform instead of SonarQube.
Which one's better?
Joseph just asked whether SonarQube or the check marks, which one is better?
They do different things. So check marks essentially scans the infrastructure as code. So it's open source project as well. At the background, it's written in the Open Policy Agent Rego language. You can clone the repo and change it. Now SonarQube scans the application code, right? They do different things.
Yep. In fact, just now when Ken, you mentioned about this, it's rather interesting. Next section, next knowledge sharing section, we invite Terraform to come, and then the following one in June, we invite checkmarks to come. So yeah, so it's rather interesting that you touch on to the next round of the participants and also the speakers as well. But before going, ending this section, if anyone have any questions, feel free to ask as well. Just thinking about, you have shown us the demo. Is there any way that we can try it out ourselves? through those demos? Because I think as we look at what you perform, it's good, but somehow it may not be so easy for us to grasp the content.
Yeah, absolutely. So I have a
yeah, we love to. If you have some free the things and guide, we'd love to give it a try.
Cool.
For that.
So what I will do is I will share, maybe not right now. After I use I ask Rishi and Otto to help me. This is essentially the demo setup guide on GCP. I'll share with you. It's just a very simple GitHub repo. And what I can also do is because I'm actually I've got a video taking you through the demo. Just what I did, but in a video format. We are producing a YouTube video or maybe on different social media platform. I will share with the group as well. But you can, if you wanted to build it, use this one. You can build it on GCP. Unfortunately, I only have a GCP version. But if you want to watch the demo again, it should be on a YouTube or something else, other platforms pretty shortly as well. It's exactly the same content, presentation and demo.
Hi, I'm Joseph Ken. What you mentioned SLAA, can I, my understanding that will be pretty much relevant to secure ops and the part of the secure coding, the framework in this part of area?
Yeah, so in Google, it's called a BCRD. It's what our software engineers use to ensure the software supply chain or software development security. So it's a checklist and standard helping you to build your software supply chain security or software development security in general.
Okay, there will be more on the development part of the security framework.
You can put it that way, yeah. Okay,
but how can I have that question. I'm not sure as a CSA member. You based on the SLSA, which part relevant to CSA framework?
CSA framework?
Yes.
As in the.
I'm asking them. I mean our member. I mean because of this related to framework and the CSA, we also have the guideline and things. So I'm trying to understand which part are linked to, relevant to SLSA.
I think firstly, let me clarify a bit. According to Joseph, what you mentioned, the CSA framework, actually, CSA does not have a specific kind of one framework. I guess what you are referring to is the cloud control matrix. That could be one of those.
Correct.
If you are referring to the cloud control matrix, then that's why I think at the very beginning when I discussed with Ken, I'm thinking of the parts that is if SLSA is more towards the part on the assessment or some kind of review part, then and also if it is more leaning towards the CI/CD cycle, then it will be more related to the development part of the cycle. That's what I thought. But if we need to map them together, then I think somehow we may need to have some further in-depth review on that part first. Right now, I don't think CSA has revised the cloud control matrix to map the cells together into this part of the cycle, but later on that could be one of the options. So not ready at this moment, what I can say.
Yeah, I think CMM is more around. Again, it's called a cloud, okay? But SLSA, it can use on-prem as well, and like Rishi said, it's more around software development lifecycle security. Whereas the CM is talking about, hey, look, what does good look like? What does good security look like in the cloud? So cloud is a precondition. It's like prefix. And there are commonalities. I'm pretty sure any big four people on the line here will be able to build mapping. But again, look, these use cases, talk to us offline. If you have a use case you'd like to explore, yeah, we can look at it, feasibility and that kind of stuff. Cool. I think we're over time.
Yes. Thanks a lot, Ken. Thanks a lot for your time, and also thanks a lot for sharing with us. Definitely, when you have something new, something interesting that you can share with us, let us know. You're definitely always welcome. Michael, it's great that you are here. Next time, do you want to arrange the time for you to talk something about?
Well, maybe many years later, not now. Ken is the champion. Ken's the expert, so.
Great.
Okay.
So thanks a lot, and remember we will have our new events coming up, and so feel free to join us and next round, and so see you and wish you have a good day. Okay, thanks.
All right.
Thanks. Bye-bye.